السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. Inshallah, today we are going to cover chapter 14 in the book Understanding Computers Today and Tomorrow. We'll study chapter 14, Databases and Database Management Systems. This chapter learning objectives are we are going to explain what is databases, including common database terminology, and list some of the advantages and disadvantages of using databases. Discuss some basic concepts and the characteristics of data, such as data hierarchy, entity relationship, and data definition. Describe the importance of data integrity, security, and privacy, and how they affect database design. Identify some basic database classifications and discuss their differences. List the common database models and discuss how they are used today. Understand how relational database is designed, created, used, and maintained, and finally describe some ways databases are used on the web. Okay, so the overview of the chapter, we are going to cover the definitions, what about the database, individuals who use them, and how the database evolved, and the next important database concepts and vocabulary. Database classifications and models, relational database, which is very common one, how databases are used on the web. So let us start with the first part of the lecture, which is giving us some definitions and some terminology about databases. So the first thing to know is that the database is a collection of related data stored in a manner that enables information to be retrieved as needed. So the database is used to store the data and to allow easier retrieval. So we would like to retrieve what is in this database. Okay. So how can we treat this database? So there is some special software called Database Management System, DBMS. It is used to create databases, to maintain databases, to access databases, and it has very special part of this program called database engine, which is doing the most important job. The most important job in databases is to store data and retrieve data that you have stored. Typical examples for database management systems are Microsoft Access, that comes with Microsoft Office, Open Office Base, Core Paradox, and Oracle database that is very common used in larger organizations. Okay, so this is database used to store data in a manner that enables information to be retrieved as needed. So this is what you must have in your database. So what are the components inside databases? So database typically consists of tables, which means every table is a collection of related records. So for example, we can make a table for the students. So all students share the same kind of information. All of them, they have ID. All of them, they have address, name, registered classes, and so on. So every student in this collection have a related information with other students in the same organization. Also, so the table, every table has rows and columns. So this is a table, has rows and it has columns. So every column from this table is called a field, and every row is called a record. So a column is a single category of data to be stored in the database. It can be here the name, telephone number, it's another field, address is another field, and so on. So this one is called row. So every student has name, ID, address, and so on. So fields or columns, a single category of data to be stored in the database, like name, telephone number, and address, whatever. And the records, which are the rows, collection of related fields in the database, all the fields for one customer, for example. Okay. So this is just giving you an example for a very simple database that has many tables. The first table for the product table, and second table for the inventory table, and the third table is for the order table. So if you look carefully here, in this inventory system, you have a table called the product table, and it has many rows, 1 2 3 4 5 rows, and every row has 1 2 3 4 columns, 4 fields. So the first row, the first column, I mean, product number. And interestingly, in the inventory table you can find also the same product number, another column here called the product number. So in these two tables, they are related, and that's why they call it relational database. They are related by how can you relate this table to that table? By this joint column. Product number here is common in these two tables, and that's why it is called a relational database, because you relate one table to another table using a common field, and here the common field was product number. In some other tables you might find the common field, not the product, it may be something else. So you have to be careful. So what is about okay, so we are storing the data in this format, in these tables: table for product, table for inventory, table for inventory on order table. But if you remember, I told you that we need to store and retrieve. So the retrieval, it means to access the data and know if there is some value. And for example, you would like to order an order, and you would like to make sure that your stock will be okay if you order this order. So if you ordered 50 items from the A211, I mean, this one, if you ordered 50, that's fine because you have 90. So this one will be okay. But the second one, you are asking for 60, and you had originally 90, and you took 50 of them. So this will not be okay. This last one will not be okay. So when you are going to doing the request for this order, you will find that the first one will pass, but the second one will pass. So the second one will not be completed. How did you know this? Because you maintain your relational database correctly, and you are querying it correctly. So once you pass this one, you will not be able to pass this other one. Be careful. Okay. So inside the database, inside every table, there must be some field called primary key. Primary key is a field that uniquely identifies the records in a table. So if you have a table, like for example this table, so what makes a product primary key? So we will give a product number as a primary key, and this primary key is very important because it uniquely defines what is this record. Okay. So the primary key is a field that uniquely identifies the records in a table. It is a field in a table that is used to relate that table to the other tables, and that we have just seen that we find that product number is in this table, which is about inventory table. We didn't use the product name, we used the product number. Why? Because product number was a primary key in the product table. And again, we used here again product number. Why? Because product number is a primary key in the product table. Okay. So for example, if you have this product table, student table, customer table, you must have this primary key. The yellow fields will always contain unique data, and so are good to use as primary keys, like product number, student ID number, customer number. The blue fields will not always contain unique data, and so are not good to use as primary keys. For example, student name, we can find some student called Muhammad Ahmad, and we can have another student called Muhammad Ahmad. So the name here is not unique. The address as well is not unique. Maybe you have many people living in the same building, so you cannot distinguish between people using their addresses or their phone numbers. but student number, student ID number is a unique identifier for this individual, for this student. Okay, so who deals with databases? Okay, from the very beginning, who designs database? We call them the database designers. Those individuals that we are going to speak about are those who are dealing with database management system. The designer designs database, the developer creates database, the programmer writes the program needed to access the database or ties the database to other programs to make some programs access this database. This is a job for a database programmer. In every organization, you have a database administrator that is responsible for managing databases within an organization, and also you have users who make queries, who enters data, who updates the data using the forms available to them. So the evolution of databases, it started very early. The concept of database is very important because you have data all the time. Every time you have large amounts of data, student enrollment, people who had subscriptions in some service, and so on. You have many types of data. So how can you store this data? At the very beginning, on 40s, they used something called the flat files. Then they moved to better representation and trees and so on, like hierarchical representation, and then network representation. On 1970s, they used the relational databases, which is a very commonly used structure nowadays. In 1980s, object-oriented databases appeared, and multidimensional databases appeared in 1990s. But still, it's a very commonly used one here is the relational databases. The most important feature that signifies the importance of relational databases is the move from here to there. Look, before the relational databases, those who are going to deal with databases must be programmers. Why? Because it doesn't separate the way to deal with the data with how to manage data. But relational databases, it has separate roles. You can have user for the database, and you can have a programmer for the database, and that's what is emphasized here in the last column. The data and the program independence has been introduced in the relational database in 1970s, and it is commonly used in these days. The data and the program are independent. So the one who writes the programs might not be the same people who may retrieve the data, for example, or deal or request and queries and so on. Okay. How you do access the data set, the database? So through commands and very low level access on the flat files, the hierarchical databases and network databases, and from the relational databases, it was high level procedural languages, non-procedural languages, I mean, that allows you to access the data. So and also it supports the one-to-one relationships, one-to-many relationships, many-to-many relationships. The variations between the relational databases and object-oriented databases and multidimensional databases are not very significant. You can still use relational databases in most of the applications in the moment, but in object-oriented databases and multidimensional databases, they can afford some more flexibility than these relational databases, and we'll cover this in the end of the lecture. So what is the advantages of using the databases? It allows low level of redundancy. So what does mean redundancy means? Redundancy means you are repeating things many times. If you are designing your database carefully, you will reach low level of redundancy. You don't have much redundancy. If you don't have much redundancy, then you have faster response time, lower storage requirement, and easier to secure because you are securing little data, low level of redundancy, and it allows you to have increased data accuracy because you don't write the same field many times in many places. So for example, if you made some mistake in one place and you did it right in some other place, then you have mismatch between these two data, so the data accuracy will be affected if you are not using database management systems. The disadvantages including increased vulnerability, which means the backup is very essential in these cases. So this is one example from file management systems before database management systems. So the tables are not related, so more time consuming and more redundancy. So if the tables are not related, this will make your life much harder. So if I have a product number here and the product number there, why don't I relate them? So that is why we use relational databases instead of using file or flat files management. So we have some concepts and the characteristics of the data that need to be understood. The data hierarchy, we have fields and columns which hold single pieces of data. The record groups the related fields for some entity. The table collection of related records like student or customer or whatever, and the database is a container of all these grouped tables. So we have a very small item which is called the field, and you collect multiple fields for the same person, so this is called row. You have many persons, so this makes one table, and you have many tables, and that will make a database. So that's why it is called hierarchy, because it goes from, so this is a database, it has many tables, table 1, table 2, table 3, and so on, and every table has many rows and every row has many columns. Okay. So what is the entity and the entity relationships? So if you have a table called student and you have a table called course, so this is an entity and this is another entity, and every entity is described by its attributes. So what is an entity? Entity may be a person, maybe an object, maybe an event of importance to the organization. Entities that the organization wants to store data about are typically becomes database table, and every entity has its own attributes. Characteristic of an entity are their attributes, typically some fields in the entity's database table, and you relate the entities to each other. So for example, I have a table for students, I have a table for courses, and I would like to relate the table of students to the table of the courses by making a new table that contains the students who are enrolled in this course. So this is a relationship. So an association between two or more entities makes a relationship. So what are the types of relationships that we have in our relational databases, or whatever? It doesn't hold for relational database only. It can be also used in other databases like object-oriented and also on the multidimensional databases. One-to-one relationship, one entity is related to only one other entity of a particular type, and this is not a very common type of a relationship that can be seen in a database. But it is very important to understand the differences between the relationships. That's why we included it here. Also, we have one-to-many relationship, and this is the very most common. This is the most common type of relationship. One entity can be related to more than one other entity. A supplier can supply more than one product. So if you have to a company, if you have a table called supplier, as you have supplier ID 1, 2, 3, 5, and so on, and you have a product, so I can, as a supplier, supply many products. So one supplier can supply many products to a company. Many to many entity relationship, one entity can be related to more than one other entity, and those entities can be related to multiple entities of the same type of the original entity. So if you have multiple suppliers and multiple products, so the product can come from many suppliers, it doesn't have to come from one supplier. So this means that you can use many to many, but if you look carefully, you can split the many to many to multiple of one to many relationships. That's why the most commonly used one is one to many relationship, but the many to many is also available for you to use. So the data definition, the process of describing the properties of data to be included in the database table. During data definition, this is the process. So you are defining your data. So you set some fields like name must be unique within the table, the name of the table. The data type, does it this field in this record is text like your name, is number like your ID, is currency, is name, date or time, a description, optional, this is optional description of the field, the properties, field size, format of the field, allowable range, if the field is required or not. Once you finish the specification for a table, becomes a table structure. And here this figure shows you the table structure. Here unfortunately the images are not of the best resolution. So the product number field is required and cannot be left blank. So you define these properties, and this is a table. This is a table. The data is entered into the table in the appropriate fields, and new record can be added. Okay, this is taken from Microsoft Access screens. So you can, if you have Microsoft Access in your computer, you can try to play with this for fun. What is a data dictionary? A data dictionary, it gives you information about what is stored in the database, contains all data definitions in the database, including table structures, security information like passwords, relationships between the tables and database, the relations, basic information about each table, such as the current number of records. So this is called the data dictionary. It doesn't contain any of the data. It doesn't contain the values of the data. The values of the data are maintained and stored in the tables themselves. But the data dictionary is just holding a metadata, which is information about the database tables, but not the database tables. Ensures that the data being entered into the database does not violate any specified criteria. So the data dictionary is made to be reviewed easily, to do the validation tests easily as well. Okay, so let us go forward to another topic of this lecture about data integrity, security, and privacy. So what do you care about your data? You care about its integrity. You care about the accuracy of the data. The quality of the data entered determines the quality of generated information. So, for example, someone is always writing Muhammad in English in a way MOHAMED, for example, and some other user write Muhammad like MOHAMMED, for example, or MUH, whatever. So you have many ways to enter the same name. So for example, now I would like to know how many students have the first name as Muhammad or Muhammad. So if you are looking for Muhammad 1 form, or looking for 2 forms, or looking for 3 forms, so if you are entering all of this data on the same way, then you can get better quality of the information. But if you allow every user to write whatever he would like to write, then they will make your life much harder. So also we care about data validation process, ensuring that the data entered is valid. For example, if you would like to enter the address and you didn't write the street name, so this is not a valid address. So you have to check record validation rules. You have to check all fields before changes to a record are saved. It can be enforced on a per transaction basis, so the entire transaction will fail if one part is invalid. For example, if you are requesting some product from Amazon and you didn't enter the address, this check must be performed, and then it will tell you there is a missing information here. Also very important about the data integrity is not to allow two individuals to change the same data at the same time, and that's why they introduced the term of database locking. So if you, for example, we have this database and we have 2 users accessing the same entity. For example, you are buying a t-shirt from Amazon, and you are buying a t-shirt, and someone else in the same time, at the same moment, is trying to buy the same t-shirt. So database locking is doing what? The first request will be processed firstly, and the second one will be locked out. So you will find, even if you are trying to put your card information and complete the transaction, you will find that this transaction is not working. Why? Because the database is locked. Why? To prevent two individuals from changing the same data at the same time. Okay. What about data security? So data integrity, it deals with the data quality, validation, and so on. What about the data security? It protects data against destruction and misuse, protects against unauthorized access to an unauthorized use of the database. So if you are a user, you are not allowed to use the privileges from some other level, like administrator. If you are administrator, you can do something that is not allowed to a programmer, or not allowed to a simple user. The database activity monitoring programs can be used to detect possible intrusions and risks. It prevents data loss. The data security should include strict backup and disaster recovery procedures and disaster recovery plans. It should be used with both in-house and the cloud databases. And so this is very important to maintain the security. And this is an example. There is some tools available to maintain the security of the database. For example, this tool, which called the DB database protect. This program secures databases and displays alerts for vulnerabilities and attacks. So it tells you highly privileged users with weak passwords, most hackable assets, and so on. So you can use such tools to make sure that your database is doing fine. What about data privacy? Your information in this database. Who gave the right to use this database? When you are entering your information, so you give them the right to know your information, but not to use your information for other purposes. So for example, if I write my name is Marwan and my email is mturki@alexu.edu.eg, then Amazon is not allowed to give this username to other entities. But if a breach happens or whatever, then I have to be notified that my personal data has been compromised. So this is very important. It is very growing concern because of vast amounts of personal data stored in databases today, and most of them are on the web now. So many of us have their own information already revealed to some other entities that we don't want them to know more about us. So the data breaches can be costly. One estimate is $200 per breached record. So if it is very sensitive data, then it might cost you more. It might cost more to get. So what about data organization? How to organize the data in your database? So this is a little bit technical, and this is not very fundamental. So we can skip it or read it. I will just read it, and you don't have to study the data organization, because it contains some information that might be above the level of this class, in the introductory class. So data organization, how to arrange the data inside the database management system for efficient retrieval. We can use indexed organization. The indexed organization is typically the same way that you use an index in the end of the book. If you have a book, for example, studying whatever, blah 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 blah, and then you have the last 30 pages about index. So the index is telling you which word appeared in which place, and this is called indexed organization. And also we have another type of organization called hashing, which is called direct organization. Instead of looking in the index, this field appeared in which record. No, I will use hashing algorithms to specify the exact storage location, to identify where this entity lies. Algorithms should be designed to limit collision. So what does it mean, limit collision? If, for example, I have many places in the disk for the data, and the hashing function is telling me to get my data from this place, and again my hashing function told me to get something else from this place. So this is called the collision. It should be the hashing function, the perfect hashing function should give you one value for every different value for every different entity, but it sometimes happens to have some collisions. Some systems use a combination of both indexed and direct organization. I will okay, so the primary key is a customer number of the record to be retrieved is entered. You would like to get information about certain products, you will write this primary key, and then the primary key is looked up in the index to determine the appropriate record number. So the record number is 15 for 101 and 10 for 102 and so on, and then you reach this customer table, you find the record here and you get this information, and the information is displayed. So this data organization is that when you are writing a query, you are a user, you're writing this primary key, and then you get retrieved this information, but in the middle this happened, and you don't care about this. If you are a user, you don't care about this. This is how the data is organized. Okay, what about the hashing? The hashing is doing something differently. The primary key in this case as customer is divided by a prime number, which means 23, for example. We took the 23 and we found this reminder. The reminder indicates the location to be used for that record. In this case it is 10, but let me ask you, how many numbers, when you divide them by 23, it will give you a reminder is equal to 10? We have lots of them. So if this happens, this will make a collision. That's why I told you there might be some collisions. Okay, now we will return to our flow again after this quiz. So only slides from 25 to 28 are not included in the exams, but I just told you about them. A column in a database in which customer names are stored would be column in a database. Of course, it's the field. Okay. True or false data validation procedures are used to ensure that the data entered in database matches a specified format and allowable value. Yes, data validation procedures check all these kind of checks. The data dictionary contains the metadata. It doesn't contain the data themselves about the tables in the database. So the data dictionary contains metadata about the database tables in a database. Okay. So again, slides from 25 to 28 are excluded from your exam. So what are the classifications for databases? We have many classifications. We will see classification depending on the user. Do we have a single user or we have multi-user database system? So the database system might have single user located on a single computer, designed to be accessed by one user, widely used for personal applications and very small businesses. The database administrator is doing everything. There's no need for a user. Other user types. Multi-user database system, it is designed to be accessed by multiple users, and most businesses database today, because we have larger enterprises and larger businesses, and we have many types of users. So this is the first classification about single user and multi-user database management systems. We have also another classification called client server and in-tier database systems. Client server means what? Means client is the front-end user who uses the database, and the server is on another place, and it's called back end. The back end contains the server, and the front end contains the users, the client. And this is very common if you go to, for example, supermarkets, large supermarkets like Fathallah and so on, that has many branches and so on. So every cashier has like a front end client, and they are all connected to one database server at the back end. Okay. So this is the client server, and we have also the n-tier database systems. The n-tier database system, it has more than 2 tiers. So a 2-tier model is called the client server. So if I asked you what is a two-tier model, so it is the client-server model. N-tier model has more than 2 tiers. There might be more tiers in the middle. We call them middleware. Additional tiers typically contain software referred as to middleware. It allows program code to be separate from the database because they are now managed by the middleware, and the code can be divided into many number of logical components. And also we have another classification for the databases, centralized versus distributed databases. Centralized means that the database is located on a single computer, such as a server. You can put the whole database in one server, that's fine, or mainframe. And it also, if the database is very large, so you need to physically divide the database into several computers connected by network. But logically it appears as a single database, so that is distributed in the storage. Means records themselves are divided into multiple places, but when you are deal with them with your code, you deal with them as one database. And this gives you the idea of the server, a centralized database system. So the whole database is stored in this one server, but here the database is distributed among these two servers, and a network is managing this communication. But what you are going to access is exactly the same way like you are accessing a centralized database. You don't feel this difference, okay? We have also disk-based database versus in-memory. So you know that the disk is very larger in storage compared to the memory, but the problem, it is very slow compared to the memory. So if your application needs speed, then you have to move your data into the memory. So that's why we use this in-memory databases for the crucial applications that need high-end systems or very fast access is required. So we have the original one is the disk-based system that the data is stored on the hard drives, and we have in-memory databases, IMDBS. Data is stored in the main memory, dramatically faster, because you know memory is much faster than the disk. Good backup procedures are essential because memory is a volatile type of data storage, while the hard disk is much more stable. And in the memory databases, these used in high-end systems where performance is crucial, and in small footprints where embedded applications where you don't have hard drives, you don't have hard disks, like your remote control, whatever. So you don't have hard disk to store anything. So, but you can access database or whatever using this in-memory thing. So a quick quiz here: which type of database system is beginning to be used in high-end systems where performance is crucial? In-memory databases. I just mentioned it a few seconds. True or false? With N-tier database models, there is at least one middle piece of software between client and server. Yes, true. Because if you don't have this one middle piece, it will become a client-server database management system. With the databases used by the system are located in a single computer, so it is centralized. Okay. So what about the database models? I told you earlier today that we are focusing more about relational databases, but for historical purposes we just give this one slide on hierarchical and network database models. The hierarchical databases organize data in tree structure exactly like your folder structure. So for example, if you have a folder, this folder has subfolders, and every subfolder has many files and so on. A typically one-to-many relationship between data entities, so this hierarchical structure is exactly the same as your folder structure. And the network database allows both one-to-many and many-to-many. That's why it's called network, because the network is connecting everything to everything. That's why it is called network databases. But neither hierarchical databases nor network databases are used today anymore. The relational database model, the RDBMS, the relational database model, the data is organized in tables related by common fields, which is called the primary keys, and if you remember, most widely used database model today. Designing a relational database, you identify the purpose, determine the tables and fields, assign the fields to a table, and reorganize as needed to minimize redundancy. You do something called normalization, and most databases stop at 3NF. Finally, you finalize the structure, primary keys, field properties, etc. So this is one example for a preliminary design for 3 tables. In the inventory database, you have a product table, product number, product name, supplier price, customer table, first name, last name, street address, city, state, zip code, phone number, balance. And this is order table. Order table doing what? It's doing a relation between a product and the customer. Who is the customer who ordered this product, what was the order date and what was the ship date and what was the quantity. So this is called the relation. So this relates two tables into one table called order table. So the order has its own primary key, which is called the order number as well. Creating a relational database, first you create the tables. Each table is created using the table structure developed during the database design process. If you use Microsoft Access, you can use the design view or the datasheet view. So you created this data, then you have to enter the data. Entering and editing data, existing data can be migrated some step. If you have older database and you like to move to another new database, you use this data migration process. And new data, if you have new data, can be added from a form or a datasheet view. In either case, same data is being manipulated. So this is, for example, tables can be created using design view or datasheet view in the Microsoft Access. And this is the forms that allow you to product entry form. You have this design, and you have this is when it is used. So you are designing the form in this way, and once you use it this way. Relating the tables, this is a step of creating the database. After you create these tables and enter the information in these tables, you relate some tables according to your study. Once all tables have been created, they can be related to one another using their primary keys. So for example, once the tables are related, data from one table, order table in this example, can be displayed within the related table, customer table in this example. So this is how you relate tables. Okay, we created the database. How to retrieve the information from a relational database? We can retrieve, which means I access this information for reviewing purpose. We use something called the query. The query is a request to see information from a database that matches a specific criteria. For example, I would like to see all the students whose first name is Muhammad. I would like to see every student who get more than 30 over 40 in the year work, and so on. Every database management system provides tools users can use to query the database for the information. And also, in addition to these tools, you can write some code like called SQL, structured query language, to get your queries retrieved. Must be designed to extract information as efficiently as possible. You don't want to write queries in a way that takes time forever to execute. Poorly written queries can impact the overall performance of the system. So querying a database, you can write your query here using SQL, or you can this is the original table, this is creating the query. You can use something called wizard with so you are trying, okay, I would like to know something about the table XYZ, and then it pulls the information from the product table. If you have a very repeated query, so it is not just one time, it is very repeated, I would like to get the overall payment in this month or whatever. So this is called the reports. It's a formatted way of looking at a database table or the results of a query. It can pull data from more than one table, and many programs have wizards or tools to make it easy to create a report, and it can be modified and customized using the design view. And they are saved in as objects in the database file. So let us see, this is one example. So for example, this is how you design the report, and this is a created report. So it shows you this customer had this total of operations this month, and so on. So the reports are typically pre-computed queries that can be run once every month or once every week or whatever. So whatever time frame you allow, it will just run and get you the information needed for. Maintaining a relational database. How to maintain the relational database? So you create a database, you queried this database, and now you are maintaining a relational database. So the table structures can be modified when needed. For example, I needed to add one more field for the student. I had earlier like name, ID, and address. Now I would like to store the enrollment date, the first time he enrolled in our faculty, for example. So if you are trying to modify, then yeah, this is the step of maintaining possible modification, adding new indices, upgrading database, deleting obsolete data, repairing, storing data, continuing to evaluate and improve security, and so on. Another model for the database that is not very commonly used, but it is available as well. It is called Object-Oriented Database Model, ODBMS. It's a database system in which multiple types of data are stored as objects along with their related code. It contains virtually any type of data. It can contain video clips, it can contain text with music, and so on. If you recall, we don't use this in the relational database. Why? Because I can always add a URL for the object and use it as a text, for example. URL, which means address. Where can I find this object? Object can be retrieved using queries as well, object query language or OQL. Objects can be reused in other applications to create new applications quickly. For example, in these law enforcement databases, you have many non-traditional data, such as photos and biometric data. And further improvement includes support to voice, iris, DNA, and palm prints, and so on. So, what about hybrid database models? Yes, we can have some model of a database that can include more than relational database. It can have a combination of two or more database types and models. For example, hybrid XML relational database can store and retrieve both XML data and relational data. XML data, it is some sort of hierarchical data. Multidimensional databases, MDDB. MDDB, multidimensional databases designed to be used with data warehousing. Data warehousing is very large space to hold very large amount of data, and it is often used in conjunction with online analytical processing, OLAP. So we have OLAP, multidimensional MOLAP, which is multidimensional OLAP that is stored in single structures called data cubes. We have ROLAP, which is relational OLAP that is stored in existing relational databases using tables or to store the summary information. And we have HOLAP, which or rich OLAP, combining MOLAP and ROLAP technology, which is mean hybrid. All these databases can be accessed typically in a warehouse or using the web. So the cloud database is typically hosted on a cloud database provider server that is accessible to the users via the web. Examples uses for these cloud databases for information retrieval, data to be accessed and displayed on a web page, often stored in database like Amazon, for example, is just when you write a product name and you are looking for it in their database and you see this information about that product, that is called information retrieval. And it supports and facilitates the e-commerce things much easier using cloud databases now. Instead of going to the store and select the t-shirt and whatever steps you are doing before buying anything, then you can do everything on the web. Cloud databases allow web pages to be dynamic web pages. Cloud databases use how cloud databases work. Visitors make requests by filling out a form, selecting an option from a menu, and web server converts the request into database query, passes it onto the database server, and then sends the results back to the visitor. The middleware connect to otherwise separate applications, such as a web server and a database management server. The web server takes the request from the user and pass it through its scripts to the database management system. So it's commonly written as a scripts, and very commonly used languages are JavaScript, Visual Basic Script, CGI scripts, active server pages, and PHP scripts. So this is just exactly one example for the use of the cloud database. The first time you went to this website and you entered in this search bar your query, and then it connects to the database server and then the web server, and then the user will be displayed with all these types of chairs, so such that this is the result. This is the result of his search query. Okay. Okay, that's it. The last quiz in this lecture. Which of the following is the most widely used of database today? Of course, no way about thinking about this. It is relational database. Relational database. Relational database. You never forget such thing. True or false? Databases are often used in conjunction with dynamic web pages. Yes, that's true. In the cloud databases, we have seen this in the last example. Whatever is used to extract specific information from a database by specifying particular conditions about the data to be retrieved, this is the query. So the query is used to extract specific information from the database. So what is the summary today? We covered what is a database, we covered data concepts and the characteristics, we covered the database classifications and models, and finally the cloud databases. This is the end of our lecture. Good luck in your coming exams, and see you. Assalamu alaikum wa rahmatullahi wa barakatuh.